Hello there, and today we're going to be working through a Mechanics 1 Edexcel past paper question focusing on moments. Now this is from the June 2011 past paper and it's question number 5. Now this is one of the moments questions where they give you a lot of information but they don't give you a diagram. So I'm going to start off by drawing a diagram for this system really. So it tells us that a plank PQR of length 8 meters and mass 20 kilograms is in equilibrium in a horizontal position on two supports at P and Q, where PQ is 6 meters. So I'm going to draw my plank horizontally, and this is going to go from P on the left hand side, Q is somewhere in the middle, and R is on the right hand side. And this is 8 meters long. Now if you read further along in the question, it says we're allowed to model the plank as a uniform rod. What that means is this mass of 20 kilograms will act right in the middle of the rod. So bang in the middle of the rod, that mass of 20 kilograms creates a force of 20 times G. Remember, G we're going to use as 9.8 newtons. Okay. Now it tells us that this plank is resting on two supports. One of them is at P and the other one is at Q, where PQ, so the distance from P along to Q, is 6 meters. So Q will be about here, and this distance from Q to R will be 2 meters if the total is 8 meters. Now a child of mass 40 kilograms stands on the plank at a distance of 2 meters from P. So this mass of 40 kilograms, that will create a force of 40 times G acting downwards, and this is at a distance of 2 meters from P. So I'm going to label this as 2 meters. And a block of mass M is placed on the plank at R. So if I just draw my block here at the end R, and this creates a downward force. If the mass is M, then the downward force will be N times G. Okay? That's meant to be a G, sorry about that. Now the plank remains horizontal and in equilibrium, and the force exerted on the plank by the support at P is equal to the force exerted on the plank by the support at Q. Now what that means is, because this plank is resting on two supports P and Q, there is a reaction force from the supports onto the plank pointing upwards, and because these are both equal, I can set them to be the same letter because we don't know what number that is at the moment. Now normally I would label these as R for reaction force, but because we have R to denote the end of the plank, I'm just going to label the reaction force at each of these as X. Now we've modelled the plank as a uniform rod, and modelling the child and the block as particles, all that means is I'm assuming that the child and the block, that their masses act at one fixed point on the plank. So this is the diagram that I've drawn. Now the question asks us, find the magnitude of the force exerted on the plank by the support at P. Now if you were to look at this diagram, there's two things we don't know. We don't know the value of the reaction force, which is X, and we also don't know the value of the mass of the block placed at R. And because we are looking for the magnitude of the force exerted on the plank by the support P, that is equal to X. Basically, this question is asking us to find X. Now what I'm going to do is I'm going to take moments about R. If I take moments at R, then I won't have to worry about M at all, because it won't even be in the equation. I'll get an equation literally relying on X. And because this plank is in equilibrium, I'm going to set moments acting in a clockwise direction, that is the two reaction forces. I'm going to set those equal to forces acting in an anti-clockwise direction, which will be the weight of the boy and the weight of the plank. And remember, for any moments equation, the moment is equal to the magnitude of the force times the distance from the point that you're taking moments at. So I'm going to make it nice and clear for the examiner. I'm going to say moments at R. Sorry for the bad handwriting. That's just to tell them what it is that I'm doing. And I'm going to set my clockwise moments, which will be X times 2, 2x, and I'm also going to have x at P, which is a distance of 8 meters from R. So that's going to be add 8x. So this is the moment at the support Q is 2x. This is the moment at the support P. Now I'm going to set this equal to moments acting in an anti-clockwise direction. So that's going to be the weight of the plank, which is 20g, and that is acting at a distance of 4 meters from R. And I'm also going to add on the weight of the boy, 40g, which will be acting at a distance of 6 meters from R. So I'm going to add on 40g times 6 meters. Now if we were to expand and simplify both sides, this would reduce to 10x is equal to 320g. And that implies that dividing both sides by 10, x, which is my reaction force at the point P, is equal to 32 times g. Now you can leave this in terms of g, or you can plug that into your calculator, setting g equal to 9.8 and work out an answer. But either way, this is acceptable. Okay? So we've found x now. Part 2 is asking us to find the value of the mass m of the block which is resting at R. Now, the way we could do this, we could take another moments equation about another point. But what I'm going to do is I'm going to resolve vertically. Because the plank is in equilibrium, I can set forces upwards equal to forces downwards. So forces upwards, if I just do a capital R with an arrow to show the examiner I'm resolving vertically, I have a reaction at P plus the same reaction at Q, and that is equal to the weight of the boy, 40g, plus the weight of the plank, which is 20g, plus the weight of the block, which is m times g. Now I know that x is equal to 32g, so this equation can be rewritten as 64g equals 60g plus mg. Bringing the 60g onto the other side tells me that 4g is equal to mg. So if I divide both sides by this factor of g, that tells me that the mass of the block is just equal to 4 kilograms. Now this part A of the question was for 10 marks, and I'm just going to show you where these marks are allocated in the mark scheme. So for part 1, knowing to take a moments equation gives you 1 method mark, and doing this correctly, it can be about any point, but it is easiest to take about R because that eliminates the mass of the block. Doing this correctly gets you 2 accuracy marks, so you get 3 marks for this line of working. And solving this to find the value of x is 1 method mark if you demonstrate that you're trying to rearrange the equation, and you get an accuracy mark for correctly finding the value of x. Now for part 2, similarly, you would get 1 method mark for knowing to resolve vertically, and another 2 accuracy marks for doing this fully correctly. Now you would also get the same marks if you were to take moments about a different point, such as P or Q. Now solving these to find m, demonstrating that is another method mark, and getting this final answer of 4 kilograms is your final accuracy mark. So that's how the 10 marks are allocated. There is a second part of this question, which is just for 1 mark, which says, state how, in your calculations, you've used the fact that the child and the block can be modelled as particles. Now, I'm not going to write this down because my handwriting's pretty awful, but essentially you just need to write something along the lines of that you have assumed that the weight of the child and the weight of the block act at 1 point on the plank. 1 point going downwards, obviously, and that would get you that final mark. So that's an 11 mark moments question from Edexcel paper on M1 in June 2011. It was question 5. Thanks ever so much for watching. I hope to see you sometime soon.